Please turn to page 24 and raise your hand so I know you are ready, okay? All right, perfect. All right, so on page 24, we're gonna start on working with more than one radicals, okay? So operation, meaning including adding and subtracting, and then multiply, right? Next page will be multiply, and then we have dividing as well, okay? I don't think we'll cover everything up to dividing, probably part of dividing, okay? That'll be pretty good progress. Okay, so let's start with the first part, add and subtract. Add and subtract, you do a similar way. So first of all, you can only combine the radicals, okay? You can only add or subtract radical if they are alike, okay? Like radicals. So if I give you two radicals, if they both have the same index, okay, you can fill this in. If they both have the same index, index means the small number on the outside, okay? For example, the 3 on the right-hand side, right? Cube root of 5, the 3 is called the index. Okay, so if it's a square root, then the 2 is the index, okay? And then the number that's inside is called a radicand. Okay, so it has to be same index and same radicand. Then we call them, they are like radical, okay? They look alike. So we can add them up, okay, if they are like radical. So for example, if I have cube root of 5 plus 7 cube root of 5, okay, then we can add it together, make it into 8 cube root of 5. So the 5 inside, you cannot add it together, okay? So 5 cube root of 5 plus cube root of 5 is not cube root of 10, okay? You cannot do adding. So it's similar to like if you have x plus 7x, it will give you 8x. Okay, a similar idea. So instead of x, we have cube root of 5. Okay, so it's kind of like adding, combining like terms. Okay, so add and subtract radicals, you have to combine the like terms. So you can add that in. Okay, this one, add and subtract, combine like terms, just like polynomial. Okay, so but you need to recognize which ones are like terms. It has to be the same index and same radicand. Okay, but then sometimes the radicands are not the same, right? Then they are not, you won't be able to add them up. So here we have an example here, 2 square root 12. I want to add it with 5 square root 3. So the first radicand is 12. And the second one is a 3, so I cannot add it together, okay? However, we can use what we learned before the break, okay? Try to simplify the radicand, okay? Simplify the square root here. For the square root of 12, what's the number, what's the perfect square I can bring it out? Okay, let's think about this, right? For square root of 12, what's the perfect square I can take out? Angeline?
2.
Yeah, I can take out the 2, and what will be left inside?
3.
Very good, okay? So the 2 times 2 square root 3 plus 5 root 3. So square root of square root of 12 simplifies into 2 root 3, right? And then outside already has a 2, right? So the outside number, they just multiply together, 4 root 3 plus 5 root 3. So now they both have the same radicand. They are both square root, so same index, right? Same inside, same outside, right? So we can add them up. So 4x plus 5x will give you 9x, right? So 4 root 3 plus 5 root 3 will be 9 square root 3. Pretty straightforward, right? Just think of it like combining like terms in polynomials, except for this one, if you are able to simplify, you need to simplify first. Okay? Can you raise your hand if you understand the examples? Okay, Kat, Mackenzie, and Tony, do you have any question about the two examples I showed above? Okay, so I guess you are ready to try the following questions. Okay, so at the bottom, you have similar ones. We start with something easy. Okay, they are all like terms, you just combine them. And then as you move down, you have something that don't look like alike, right? But then after you simplify, you can combine. Okay, so I'll let you guys do all 8 of them. Okay, and then I'll pick some of you to show your answers on the screen. So when you finish all the 8 questions, you can raise your hand. Okay, well, we will go over in 5 minutes. Okay, I think 5 minutes should be enough. Okay, first 4 questions are pretty easy. You don't need to simplify the radicals. They're all like terms. No, we already have people finished. 08. Okay, Tony, which question are you working on now?
I'm working on E and H.
Okay. And how about Wilson?
I just
I'm working on E right now.
Question E? Okay.
Yeah.
Right, so I'll be writing the names on the screen and then you can show your work. For the easy ones, I guess you could just write the answer, okay? Like for A to D, okay? I don't think there's not much work to show. But for E, F, G, H, please show the first couple line. Like first line, you need to simplify, right? And then you combine the like terms. So at least 2 lines. Okay, so if you see your name, you can begin writing on the screen, okay?
22的4， 525。
Okay, very good effort. I see a lot of you are trying to write with a mouse. Okay, so Wilson, for square root 75, the 5 should go in front of root 3, okay? So you can write 5 square root 3.
Wait, like this?
No, 5 square root, 5 square. 5
Oh,
goes out, right? 5 goes on the outside. 5 on the outside, square root of 3. Right, this is for square root of 75 for the first term. Yeah. And then you do similar for the 48 and also simplify the 27.
Wait, how do you factor it down? Because I'm a little confused.
You need to find a perfect square. So for example, if you look at question E, okay, let me pull that out, okay? For question E, for the first number, right, square root 50, do you see the arrow I'm drawing?
Yeah.
Okay. So you draw the factor boxes, right? So remember we did this before the break. What number can divide into 50?
5,
5.
or 10.
And then what do you get?
10, and then
Yeah. And then any more?
yeah, 5 again.
Yeah. And you get
2.
2, right? So you stop until the answer is a prime number. So 2 is a prime number. So we just stop there. Okay. So no point to continue dividing. So now you look at all the numbers on the outside, the 5, the 5, the 2. If you get a pair, you have a pair of 5, then that pair will go out. So makes a 5 on the outside. The one that's alone, you keep it inside. So 5 square root 2. So that's why on the answer key, Geoffrey wrote down 5 square root 2. Understand now?
Yeah, okay.
Okay, so you have to do that for each of them before you combine the like terms.
Wait, what if they're like for 27? What if they're just all three?
So you only get pairs, right? Because this one is square root, so you find a pair of 3 to go out. It has to be a big 3, not cube root. Your 3 is too small, right? You have to write a big 3.
Wait, is it not cube root though?
It's not cube root. The question is square root, so it will remain square root the whole way.
No, but then if it was square root, then it wouldn't equal to 27.
Can you say that again? If
If
it's
it was square root, then it wouldn't equal to 27, would it?
square root wouldn't equal to 27. So 27, you have 3 times 3 times 3, right?
Yeah.
Yeah, so this here you get a pair of 3. So this 3 will go outside. And then the one that's left alone, you keep it
Mhm.
inside.
Oh, okay, yeah. That's what you're trying to say.
Okay, and yeah, and you need to fix the one for the 48 is not 2 on the outside. You can try again.
Is it not 2 on the outside?
Nope. How do you break down the 48?
You can put in 2 and then 24, 12, 6.
2, and then what?
And then it's 4 groups of 2, like 4 twos and then 1 3.
So 2, 2, 2, 2, and the 3, right?
Yeah.
Yeah, so you get a pair of 2. Do we have another pair?
Yeah.
Yeah, so we have another pair of 2. So those 2 pairs will go out. So you have 2 2s goes out. So what makes it go outside then at the end?
Wait, hang on.
2 goes out, and then another 2 goes out. So what's on the
What?
outside then?
Is it 4?
Yeah. When they go out, they multiply together at the outside, okay? All right, and then you need to combine the like terms. Okay, did everyone else finish? Okay, so let's go over the answers, right? So first one, very straightforward, you just add them up, right? Subtract 4 minus 3 plus 7, right? Very good. And then next one, okay, the first question B, okay, for the first term is 1 square root 2, right? They didn't show it, but you can treat it like 1. So 1 minus 3 plus 9 minus 11. Okay, so you get negative 4 square root 2. And then the next one, okay, it looks like Aaron, he reordered it first, right? He put all the like terms together, right? The negative 2 root 6 and 5 root 6 put it together. And then the 7 root 3, all the root 3 put together. Okay, so you have 3 root 6 plus 4 root 3. Okay, that's correct as well. Next one, same thing. Okay, and the root 6 has no one to combine with, so you just copy it. Okay, starting from question E, you need to simplify each one if possible. Okay, that's correct. Negative root 7. Yeah, that's good. This one we just went over. Okay, and then for question H, yeah, so the difference between this one and the other one is on the outside already has some numbers, right? Has a 2, has a 3 waiting outside. So whatever that comes out, it will need to multiply with the outside number. Okay, so that's why you have 4 and 15 and 12. Okay, and then at the end you get root 5. Yeah, that's also correct. Okay, if you have any mistake, okay, you can check your steps. Okay, and then if you are ready to move on, if you wrote down everything, you can raise your hand, and then we'll move on to next page. Okay, we'll be starting to look at multiplications. Because once I move the page, you won't be able to see the work. Okay, so make sure you copy the things down. The work that you wrote on the screen, I cannot save it to the file. Okay, I'll just write the answer on the side. Okay, if you are ready to move on, please raise your hand. Okay, so let me clear your drawing now. Okay, so oops. Okay, so let's go to next page. Next page is for multiplying and divide. For multiplying and divide, the rule is less. Okay, if you want to add and subtract, you need to have index and the radicand both has to be the same. Okay, to be like terms. But for multiplying, it doesn't have to be like terms. Okay, think about when you are multiplying polynomials. Okay, let me erase this part. For example, if you want to multiply x squared, right? This one has the same x, right? And then same base with x to the cube, but different exponent. So even though they have different exponent, I can still multiply, right? Then that will give you x to the 5. Add the exponent. But if it's adding and subtracting, right? If I want to add them up, I can't do it. Okay, I cannot add it together and then say equals to what? Or I just can't. I can't do anything. Okay, so multiplying, it's okay to have different exponent. So same thing here. All you need to do is to have the same radicand. Exponent can be different. Exponent here is kind of like the index. Okay, index is like the exponent. So index can be different. Wait, hold on. Both must have the same index. Sorry. Okay. My bad. Okay. Index. So for example, you have 4 square root 2 and square root of 3. Their index is 2, right? Because it's square root. Right? So both have index equal to 2. So you will be able to multiply them or divide them. Okay. So let's look at an example here. So you look at the two terms, they are both square root, so we can multiply together. So outside number is 4 and 1. Okay, so 4 times 1 give you 4. Inside number times the inside number, so you get square root of 12. Okay, now after you multiply that, you have to make sure it's simplified. So you look at this part. square root of 12, I can break it down, right? You get a pair of 2 that can go out. So 2 goes out, meets the 4. Okay, I'll show the step. So that makes an 8 on the outside. Okay, so don't just stop right after you multiply. Keep on checking, see if you can simplify anything, right? Take anything out. Okay, let's look at an example that's more complicated. Okay, you have something at the top, something at the bottom. Okay, so usually we separate them first. We'll just do the top part first. Okay, multiply the top, the bottom part will keep it there. So Tony, can you multiply the numerators together and tell me what you have?
I have 48 for the radicand,
Yeah.
and then I have 10 on the index.
10 is not the index. You just say it's the number outside.
Number
Index,
outside.
index is the 2.
Oh,
Okay?
yeah.
Yeah,
Yeah.
index is the small number, right?
Okay.
And then the bottom is the same thing. Okay, we'll keep it there.
Yeah.
Okay. So now here we have a dividing. For dividing, just like the multiplying, outside number divide with the outside number, inside number divide with the inside number. Okay, so what you can do is you can write it like this: 10 over 25, right? That's outside with the outside, right? And the ones that are inside, you can put 48 divided by 48, right? Inside divide with inside. So of course, 48 and 48 that divide each other, that becomes just a 1, right? They are the same. And square root of 1 is just 1, right? So nothing to do there. So 1 will become invisible. And we reduce that. 10 over 25, we can reduce it down to divide by 5, right? So that will be 2 over 5. So general rule is if you want to multiply and divide, make sure your index are the same. And then you just do inside with the inside, outside number with the outside numbers. Okay? And make sure you simplify, double check if the radicand can be simplified anymore. So let you try these 6 questions, okay? And when you finish these 6, you can raise your hand. So another 5 minutes, and then we'll go over these 6 questions, and I'll assign name to each one as well, okay? Okay, you may begin writing on the screen. I'll do the first one, okay? 2 times 3, all right, there you go, okay? So root 6 cannot be simplified anymore. Okay, looks like everyone finished, okay? Can you check your answers with these one? Does anyone have anything different? Anyone got different answer for any of them? Okay, if you got all the same, please raise your hand. Two. Oh, it was. Okay, okay. Yeah, Kat, I saw your message. Okay. Yeah, I was thinking, oh, should I put 2T? Then I check your name. I saw 2T's. Okay. No problem. Okay, so Bernice, you have anything different? I didn't see you raise your hand. If you got everything the same, please raise your hand. Okay, Wilson, which one are you working on right now?
I finished all of them.
Do you have any answer that's different?
Let me see. No, my answers are all the same. Yeah.
Okay, that's pretty good. All right, so yeah, these ones are pretty straightforward, right? Just inside times inside, outside times outside numbers, and simplify each one. Okay, so no, I don't see any problem here. They all seem correct. For the last one, question F. Yeah, all the steps are pretty good. Okay, yeah. So for this part, square root of 1/4, right? You could also think of it like square root of 1 over square root of 4. and that will give you 1/2, right? If you are wondering how we get a 1/2. So you can either put the insides together or you could also split it, right? So you can only do that if it's purely just multiply and divide, then you can do it this way. Okay, so final answer is 1 for this one. Okay, so everything is good here. So let's move on to the next page, okay? Clear the drawing here. So far, I don't think it's too difficult, right? So starting from next one, we'll need more thinking when you are doing it. So in grade 9, I think, or in grade 10, you learn some polynomial formulas. I don't know if you remember it, right? For a plus b in bracket squared. So for example, like you can use it for a question like this, 2x plus 5 squared, right? You have a is the 2x, b is the 5, and then if you apply the formula, then you don't need to use FOIL, right? So anyone here remember the first formula, a plus b bracket squared? Help us out. Does anyone remember? Aaron, do you remember?
For me, I just take it out like a plus b bracket and then multiply a plus b bracket.
Oh, okay. And then we can derive the formula this way then.
Yes, like that way.
Yeah, and then can you expand this and tell me what you got after you multiply that?
I did FOIL, so it's a squared plus 2ab and then b squared.
Oh, okay.
Yeah.
Yeah. Okay. Okay. So if you do FOIL, actually there should be 4 terms. I'll show the steps here. So plus AB plus BA equal B squared. Oh, sorry, plus B squared, and then ends up with A squared plus 2AB plus B squared. Okay, so this is the part that you need to memorize. Okay, whenever you see A plus B bracket squared. So in a similar way, we can expand the a minus b squared. So Geoffrey, can you help us find the formula for this one, for the second one? Geoffrey?
What?
Yeah, for the second one, do you know the formula?
No, I don't remember.
Then let's expand it. How do you expand the a minus b squared?
I think it's a minus b times a minus b.
That's right. Okay, just like the first one. And then can you multiply it out?
In a squared minus ab minus ba plus b squared.
Okay, and can we combine any like terms?
ab and ba. So a squared minus 2ab plus b squared.
Yeah, plus b squared. Okay, so this is our second formula. I hope this help you refresh your memory.
Wait,
And then the third one is a plus b times a minus b. Jenny, do you remember the formula for this one?
No.
Then let's expand it as well and find out. Okay, so you can do the FOIL.
So it would be a squared.
Yeah. Yeah, a times a. And then,
Minus AB.
yeah. So that's these two. Go on.
Plus BA
So that would be these two.
and minus B squared.
minus b squared. Okay, can we combine anything?
Minus AB plus BA.
And what will happen then?
They cancel out.
Yeah, they're opposite signs, right? So what's left then?
A squared minus B squared.
Yes, okay, so for the third one, actually, we have a name for it. It's called the difference of squares. Because you see in the middle, you have subtraction. That's called difference. And then each of the term got squared. Okay, so it's called difference of squares. You can write that on the side. Difference of squares. The two squares, they subtract each other. Okay, so please copy these down into the boxes and raise your hand, and then we'll look at some example how to apply them. So because we don't want to do FOIL every time we see these things, right? The a plus b squared, and we don't want to write a bracket FOIL, right? It takes too many steps. So you need to memorize the result in the red box, okay? So whenever you see the bracket square, you go directly to the end result, okay? So that's what the formulas are for. Is to help you save time and work. Okay, so please raise your hand if you finished copying everything here so far. Okay, Anya and Tony, do you need more time? Okay, so let's look at our question A, okay? First example here. For question A, which formula do we use? Does it have to do with 1, 2, or 3? Tony, which one do you think we need to use?
For which one?
For question A, this is
Um,
question A. Does it look like Formula 1 or Formula 2 or Formula 3?
Formula 1.
All right, so if it looks like Formula 1, then what's the A?
For the 4 root 11.
Yeah, and what's the B?
5 root 2.
Very good. Okay, so let's use that. So let me write it down. So this part is the A. This part is the B. Okay, so based on the formula, we know that it will equal to A squared plus 2AB, okay, plus B squared. So fill in the A and B into the brackets, okay? So A is 4 root 11. B is 5 root 2, right? And in the middle, you have 2AB. Any questions so far? So make sure you put brackets, okay? So it doesn't look too messy if instead of writing multiplication signs. Okay, and can you please raise your hand if you are done with this line? Okay. Before I move on, okay, let me know when you finish this line. So this is the work I would like to see when you are doing the homework, okay? write out how you place the number into the formula. Okay, please raise your hand if you finished writing the first line here. Okay, Kat and Tony, do you need more time?
Are we doing B?
No, we're still on A. Are you done B? Are you done A already?
I don't know if I did it right or not.
So you finished this line, right?
I think so.
Okay, so next we are going to find out each part, okay? For the square, square means times itself, right? You can think on the side, 4 root 11 times 4 root 11. So outside times outside, inside times inside, we learned that on the last page, right? So that will give you 16 times, okay, square root of 11 times square root of 11. The square and square root will cancel each other out. So that will just make it 11. Okay, so another way you can think of it is like you share in the exponents. Square the 4, square the square root 11. Okay, when you square the 4, give you 16. When you square the square root, it cancels each other out. Any questions so far? Okay, so that's the first part. And then the next term, this term in the center, all the outside number, the 4, the 2, the 4, the 5, they multiply. Okay, so 2 times 4, 8, 8 times 5, 40, right? And then inside times inside give you 22. Okay, outside, outside, inside times inside. Okay, third one. I'll let you try this one. What's
I
the
have a question.
Yeah, Tony?
How did you get the 40?
Okay, all the outside numbers I'll highlight it. Okay, you have the 2, you have 4, you have 5.
Yeah,
What's 2 times 4
8.
times 5?
Oh, 40.
That's right. Okay, all the outside number times each other and the inside number times each other. Okay,
Okay.
then can you do the third one, Tony? Okay, the last part, last bracket.
Okay, so for the last bracket, which is 5 is squared, right? So that will be 25 through 25 times 2.
That's right. Okay. And then final step, we just simplify everything. What's 16 times 11? Okay, somebody help us out. Mackenzie, what is 16 times 11? Mackenzie? Yeah.
176.
Huh?
170.
Okay, Tony, yeah, I heard you. Are you here, Mackenzie? Okay, all right. All right, so 176. 40 square root 22. So make sure you double check. Can we simplify the 22? Take anything out. Valerie, can we simplify square root 22?
No.
Okay, so that one has to stay. Okay, so we just keep it there. 25 times 2, that's a 50. Okay, so now we combine the like terms. So now it becomes an adding question, right? So 40, 22, stay there. and then they add together. That should give you what? 226. Okay, so that's it. Okay, you cannot add them up because they are not like terms. So you would leave your answer like that. Okay, so the common mistake is I see people, even though I go over this, but then in homework, you start to square each one. That's wrong, okay? You have to use the formula. So at the end, right, even though you end up with just 2 terms, but in between, there are actually 3 parts that you need to simplify, okay? A squared plus 2ab plus b squared. It's not just simply square each one of them, okay? So please remember that. But I'm sure, even though I keep saying it, I probably will catch 1 or 2, still square each one, okay? So make sure you have your notes beside you so you don't forget. Let's have a break, okay, before we finish the other questions. We'll come back at 2:50. Okay. If you have questions, you can ask me during the break.
Hi, Jason.